Suppose this is some graph between y and x, and we need to find the slope of this graph at point P. So slope tells basically about the inclination from the positive x-axis. So to do that, we'll make a tangent at that point like this. Suppose this is the tangent at the point where we need to find the slope, and if that tangent makes an angle theta, so slope at P is dy by dx, rate of change of y with respect to x at P, and if the slope makes angle theta from the positive x-axis, so that is also tan theta. And here this is a y-axis. Again, the y and x are the general. In physics the name will keep on changing. And suppose this is a PQ axis, then the slope will be dp by dq. This is a tu, then the slope will be dt by du, and whatever this name. So accordingly, if this is y and this is x, so slope here is dy by dx, and according to the name will change, this slope will also be, this equation will also change. But whatever it is, if the tangent makes angle theta, the slope is always tan theta. And there is another thing, the area bounded by curve from the x-axis. So this is a y-axis, this is x-axis, and this is a graph of y is equal to fx, and we have to find the graph bounded by this curve and x-axis from x1 to x2. So this area is whatever is on this axis, put it here, whatever on this axis, write d of that thing, and then the limits of x from here to here. So the limits of this is x1 to x2, so that will give me the area bounded by the curve y is equal to fx, and x-axis from x1 to x2. In the physics again the name will change. So for example, if I take, suppose this is say v, and this is t, and this is say T1, and this is T2, then what the area will become? Now the area will become integration of whatever is on the vertical axis, write it here, whatever is on the horizontal axis, write a d of that thing, so dt, and the limit will be whatever from where to where we have to take area on the horizontal axis, so that is T1 to T2. And the same way we can write the area of any curve bounded by the horizontal axis between two limits. And one important thing to consider, that this is not the area that we used to study before 11. Before 11, the area that you studied is always positive. Here these are the coordinates. Coordinates can be positive, negative. Suppose for example this is y. If the graph is below this axis, then the y will be negative, then this area will come out to be negative. So this area can be positive or negative. So if the graph is above horizontal x-axis, then the area bounded by the graph and the horizontal axis will be positive, because then the y is positive, and the graph is lying below the horizontal axis, then the area bounded by the graph and the horizontal axis will be negative. So if we know these two things and just are swift enough to immediately changing the variable from x, y and x to v and t, or x and t, or v and x, or whatever, our 99% problem of the kinematics is immediately done. So let's see how. So three important kinematical graphs are position time graph, velocity time graph, and acceleration time graph. And two important things that we can tell from the graph are from the slope and area. The slope and the area tells a lot of things about the graph, and I just told that the slope of yx graph is dy by dx. The slope of xt graph would be, and one more thing, when I write xt, so whatever I write the first, that will be on the vertical axis, and whatever I write second, that will be on the horizontal axis. The slope of yx graph was dy by dx. The slope of xt graph would be what? Dx by dt. And you know what is dx by dt in the rectilinear motion? That is the velocity. So one thing that you come to know, that the slope of position time graph will give you velocity. And the same way, the slope of velocity time graph will be what? That will be dv by dt. And what is dv by dt? Dv by dt, you know, is the acceleration. You should remember this is velocity, not speed. So dv by dt, the slope of velocity time graph will give you acceleration. The slope of AT graph will be dA by dt, and dA by dt, some people will say it is a jerk will say it is jerk, but that is not a physical quantity, so that will not be useful thing physically for us. And now the area under, let's start from here. Area bounded by acceleration and time axis, like the area bounded by y and x axis, that was the integration of y dx. So that will be the integration of a dt, and suppose we want this area from the between time t1 to t2, so that will be this thing. We will see the meaning of this thing. And the same way, area bounded by the area of a velocity time graph between time t1 to t2 will be integration of v dt from t1 to t2, and this area would be integration of x dt t1 to t2. And you know that v is equal to dx by dt, so dx is equal to v dt. Suppose particle is moving, it is moving, so with time its position is changing. So suppose at time t1 position was x1, at time t2 position is x2. So what is the left hand side? Left hand side is integration will give x2 minus x1, final position minus initial position, that is displacement. And what is the right hand side? Don't you think that this is the right hand side? And the left hand side is x2 minus x1, that is displacement. So this area under VT graph gives us the displacement. The area under VT graph in a given time interval gives the displacement covered by that interval, covered in that interval. And the same way, A is equal to dv by dt. A is equal to dv by dt, so dv is equal to integrate a dt, and suppose particle is accelerating, velocity is changing. At time t1 velocity is v1, at time t2 velocity is v2. So what is this integration? v2 minus v1, change in velocity, and this integration is this thing. So this thing is v2 minus v1, and what is v2 minus v1 is change in velocity. So this is also change, this is change in position, this is change in velocity, and there is no variable less than x here. So this will not give us any meaningful thing. So this is not giving us any meaningful thing, and this area of xt graph is not giving us any meaningful thing. These two areas are giving meaningful things. So this is a change in velocity, change in velocity, this is change in position, this slope is velocity, this slope is acceleration. So just by this basic idea we got so many things. And now we'll proceed towards the some starting graph like position time, displacement time, velocity time, speed time, acceleration time, their interdependence. But the basic idea is the same. We have to plot the functional form into the graph. That's what we have to do.